protons, neutrons, electrons. The central part of an atom is the nucleus. This central region that you see. Yes, Shahnawar, I'll explain that again. I'm just letting you guys know the subatomic particles first before I explain that again. This central region, this centralmost region that you see, this is known as the nucleus of an atom. In this nucleus of an atom, we have two subatomic particles. In total, we have three subatomic particles: protons, neutrons, electrons. It is written here as well. These are the three subatomic particles that we have in our syllabus. In the nucleus, you'll find two of those: protons plus neutrons. Protons and neutrons would be in the nucleus, in the central part of an atom. Outside the nucleus, we have energy levels, or we have shells. In these shells, we have electrons, the third subatomic particles. So within the nucleus, we have protons and neutrons. Outside the nucleus, we have electrons. There are a few properties that you guys need to know about these subatomic particles. First thing that you need to know is the charges on these subatomic particles. Electrons, they have a negative charge. Electrons are negatively charged. Protons are positively charged, +1 basically, and for electrons, -1. For neutron, it is electrically neutral. Neutral means zero charge, uncharged. The second data point that you need to know about these subatomic particles, their masses. Protons have a relative atomic mass of 1, neutron have a mass of 1, but electrons, they have a negligible mass, close to no mass. That mass, we call it 1/1840. What we mean by 1/1840 is, if we have 1840 electrons, their combined mass would be equal to just one proton or one neutron. This is what it means. So if we take a beam balance, on one side, if we just put one proton or one neutron, and on the other side, if we put 1840 electrons, they will balance. So electrons, they have a negligible mass, very small mass. So this is what the structure of atom is. In the central part, we have the nucleus, which has protons and neutrons. Outside the nucleus, we have energy levels or shells. In those shells, we have electrons. This is known as energy level. Or we sometimes call it shells as well. So in these shells, we have electrons. So you are expected to know this table, which we just discussed. Proton mass, relative mass 1, neutron relative mass 1, electron 1/1840, negligible, close to no mass. The charges: proton +1, electron -1, neutron 0 charge. So what would be the charge of the nucleus in that case? If we have protons and neutrons in the nucleus, what is the charge of the nucleus? Yes, nucleus is positively charged. Nucleus is positively charged. But what about the charge on an atom? The entire atom, the entire structure here. Yes, the entire atom would have a 0 charge, because the protons and electrons, they would balance each other out. We have electrons negatively charged, we have protons positively charged. So they cancel each other out. So the entire atom, this whole atom, combined with electrons and neutrons, this carbon atom, this whole thing is neutral. But this is neutral, but just the nucleus bit, just the nucleus, that is positively charged, because nucleus only has protons and neutrons. It doesn't have any electrons. Because in the nucleus there are no electrons. Electrons are outside the nucleus, aren't they? They are in the shells. They are not in the nucleus. I hope this has made sense. Any other questions? Okay, now this is our structure for lithium. We just discussed the structure, or the symbol is Li. Bottom left, we have 3. Basically, we write the proton number here. Top left, we have the mass number, which is 7 for lithium. This bottom number, basically the smaller number, just think of it as the smaller number, because in the periodic table it can be different as well. At the bottom you can have the bigger number, at top you can have the smaller number, right? So just think of it as the smaller number would be your proton number. Another way of saying the proton number is the atomic number. The number at the top that you see, the bigger number is your mass number. We sometimes call it nucleon number as well. Nucleon number. This nucleon number, this 7 here for lithium, this is protons plus neutrons combined. Sure, Abdul Rafi, sure. This would be protons plus neutrons combined, the sum. If you want to calculate the protons here, if you want to know the protons are 3. Electrons would be equal to protons. Protons is equal to electrons for an atom. We are not discussing ions right now. Electrons would be the same as protons for us. So that would be 3 as well. Electrons are also 3. To know the number of neutrons, just do bigger number minus smaller number. Neutrons would be your mass number minus proton number. This will give you the number of neutrons. So I'll do 7 minus 3 is equal to 4. Has this made sense? Has this made sense? So this number at the bottom left, the smaller number basically is your proton number, the bigger number is your mass number. Let me go to the periodic table, and now we can try doing some of these elements. Okay, now I'll discuss fluorine here, F. I'll just write the smaller number at the bottom left and the bigger number here, which is 19, right? How many protons do I have? The smaller number is the proton number, 9. How many electrons? Electrons are same as protons, 9. Electrons are same as protons. The number of neutrons, bigger number minus smaller number. Mass number minus the proton number. So number of neutrons, 10. Right? Is this making sense? Shanawaz, is this clear now? Another example, let's take which one? Let's take phosphorus here. P. I am just writing the smaller number at the bottom left here, and at the top left I'm writing the bigger number. 31 is the bigger number. So number of protons, the smaller number 15. Number of electrons same as the number of protons, 15. Number of neutrons, 31 minus 15, 16. Is this clear? Any doubts? Any doubts here? Are there any doubts? Okay, I just have to go for prayer. I'll be back in a bit. Meanwhile, you guys can attempt these MCQs. When I come back, I'll explain these MCQs as well as we'll do the next concepts, right? Those who want to pray, as like a couple of students said, you guys can pray as well. I'll be back in a bit. We'll see MCQs, solve them. When I come back, I'll explain these MCQs. We'll do the next concepts. Okay, we'll first discuss the concepts of the day. Then we'll move to these MCQs. I'll explain all these multiple choice questions. But first, let us complete today's concepts.